Okay, the last type of division that we want to talk about is synthetic division. And synthetic division is a shortcut of long division, but it doesn't work on all division problems. It only works when we have a divisor in the form of x minus c. That's the only way we can use synthetic division, but for our purposes, that's going to be mainly the reason why we use it. So in this first division problem, I have a polynomial being divided by a binomial. It is of the form x minus c because this x has a coefficient of 1, which is what I need it to have, and this x also has the highest power of 1. In other words, it's only raised to the first degree, which is what I need it to be. So it's already in the form x minus c. So this is our c, and we take that 2 and we pull it straight out, and we write it like that with this strange little division sign. And in synthetic division, we're only concerned with the coefficients of our dividend. Okay, so I'm going to look at the coefficient here, which is a 1, a positive 2, and a negative 8. We're going to leave a little space, and we're going to draw a line. And the hardest part about synthetic division is getting it set up because it's a repeated operation once we get going on this. You always want to start by bringing the 1 or your first term straight down. And this is where we're going to begin the synthetic division process. It is repeated multiplication and then addition. So I'm going to multiply 2 times 1, and I'm going to write this right here, and then I'm going to add straight down. 2 plus 2 is 4. Let's try that again. 2 times 4 is 8, and then I'm going to add straight down to get a 0. Now what all this means is, for one, when I ended here, I don't have any more numbers to deal with. This 0 tells me my remainder is 0. That's good. And now I'm going to convert these coefficients into my answer. When we write synthetic division, our answer is always going to be 1 less than the power that we started with. In this case, I started with an x squared, so my answer is going to be x. The coefficient of that is 1. And then we just write the next term plus 4. So that's the answer. Synthetic division is really fast. As long as we learn the process and how to set it up, it doesn't take that long to work. Let's work one more, a couple more actually. Let's look at this one right here. Once again, I have a polynomial being divided by a binomial whose highest power is 1. The coefficient is 1, and it is of the form x minus c. In this example, I just pull my 2 out again, as is. It's a 2, positive 2. And I rewrite my synthetic division, or I set it up only with the coefficients in front of my terms. So I have a 5, a negative 4, and a negative 9. I leave a little space, and then I start the process. I always start by bringing the first term straight down, and then I multiply. 2 times 5 is 10, and then I'm going to add straight down. Negative 4 plus 10 is 6. 2 times 6 is 12. Add straight down, I get 3. This last number here tells me that I have a remainder of 3. Now let's write the answer. If my dividend, or my original polynomial, started with the highest power again of x squared, then my answer is going to start as an x. The 5 is the coefficient. Here this is a 6, positive 6, and I write my remainder just like I wrote it using long division, where I put my remainder in the numerator, and I use the divisor of x minus 2 as the denominator. And there is my answer for this synthetic problem. Let's try that again. Here we have a problem. I have a polynomial being divided by a binomial whose coefficient is 1. The highest power of this binomial is 1, so it is of the form x minus c. The only catch I have is I have a plus sign instead of a minus sign. If that's the case, then whenever you take this 2/3 and write it out here to set up our synthetic division, we just need to write it with a minus sign. And that will take care of turning it back into this form, because a minus times a plus gives me a minus. So just remember that if you start out with x plus something, when you take that c out, you change it to a negative. Now let's rewrite 9 plus 9 minus 1 plus 2. We'll leave a little bit of room here again, and we will multiply. First, we're going to bring our 9 straight down. I get a 9. And now I'm going to multiply negative 2/3 times 9. And I'll do that off to the side just so we can remember. Negative 2/3 times 9 gives me, this 3 divides into that 9 3 times, so I have a negative 6. And now I'm going to add straight down. So I get a positive 3. Negative 2/3 times a positive 3 is negative 2. Add straight down, I get negative 3. Negative 2/3 times negative 3 gives me a positive 2. Add straight down, I end up with 4. So I'm going to have a remainder. That's what this 4 tells me. And now I just need to figure out how to write my answer. In this particular problem, my highest power was x to the 3rd, and I always start my answer 1 less than that. So my answer is going to start out as x squared. Here's the coefficient for my first term, and we go from there. 9x squared plus 3x minus 3 plus 4 over my divisor of x plus 2/3. And that's the answer to that division problem. Just wanting you to make sure that you see that if I have a plus sign here, when I take out this c and write it over here, I have to write it as a negative. So let's practice that again. I have a polynomial being divided by a binomial that has the x has a coefficient of 1. It has a power of 1, so I can use synthetic division. That's a good thing. We like synthetic division. And I'm going to rewrite this as negative 3 because of that sign right there. And then I'm going to use my coefficients of 1, 2, and 4. Draw my line. Bring my 1 down because that's where I start. And now I multiply negative 3 times 1 is negative 3. Add straight down, I get negative 1. Negative 3 times a negative 1 is a positive 3. Add straight down, I get 7. I'm going to have a remainder, and when I rewrite my answer, I look up here to the original polynomial. The highest power was x squared, so that's where I go 1 less than that, so I start with an x. My coefficient is 1 minus 1 plus my remainder of 7 over x plus 3. So my answer is x minus 1 plus 7 over x plus 3. Okay. Just like we did our problem using long division, I want to come back and I want to revisit this same problem doing synthetic division. We can do this problem using long division because long division works for all division, or we can do this problem using synthetic division because it is of the form x minus c. And synthetic division is much easier because we're only multiplying and adding when we do our process. So let's set this up. This is already of the same form, so I just need to write my 3 out to the side. I'm starting with an x to the 4th, but just like before how we had to hold our place values, this is the x to the 4th place, x cubed, x squared, x to the 1st, x to the 0. And I'm missing these 3 terms in the middle, but I need to put a coefficient there for them to hold their place. So right here, instead of writing x to the 4, I should have written 1 because that's the coefficient. I'm going to write a 0 for the coefficient of x cubed, a 0 for x squared, a 0 for x to the 1st, and this is where 81 comes in down here at the end. 81. Now let's draw our line and do our synthetic division. We bring the 1 straight down and off we go. 3 times 1 is 3. Add straight down, we get 3. 3 times 3 is 9. Add straight down, we get 9. 3 times 3 is 3 times 9 is 27. Add straight down, 27. 3 times 27, 81. Add straight down, 162. This is my remainder, and I start with this term right here to write my answer. Since the power of my polynomial was raised to the 4th degree, I start out raising it to the 3rd. My coefficient is 1, so that just stays, and then I just write them in descending order from there. Plus 3x squared plus 9x plus 27 plus 162 over x minus 3. And if you go back and check your notes from the long division section, you'll see that that's exactly the same answer, but a whole lot easier than doing long division. Don't get me wrong, long division has its purpose, but synthetic division, if we can use it because it's in this form, that's probably the choice we want to make. Now the last thing I want to talk about is something called the remainder theorem, and it's not really that important to understand, I suppose. Just let me explain to you what the remainder theorem is, and somehow my stuff got moved. Let me explain to you what the remainder theorem is and how you're going to apply it to your homework, and then come back and revisit the remainder theorem again when you see it in college algebra. Let's say that I wanted to write a polynomial p of x is equal to x cubed plus 3x squared plus, minus 3x plus 5. And I want to know what happens to this polynomial when I evaluate it for x equals 1. Well, how do I do that? All I do is I take this 1 and I plug it in for every single x that I have in this, for every single x that's in this original polynomial. Remember, we did this when we studied functions. So p of 1 is equal to 1 cubed plus 3 times 1 squared minus 3 times 1 plus 5, which is really equal to 1 plus 3 minus 3 plus 5. So my answer is 6. So if I substitute 1 into my polynomial, I find out that at p of 1, the answer is 6. The remainder theorem is going to tell us that I can find that same answer if I were to divide my polynomial. If I divided this polynomial by x minus c, or in this case, x minus 1, I'm going to end up with a remainder of 6. So for the purposes of your homework, I'm going to show you how to do that. You can come back and you can think about this a lot harder when you get to college algebra. So let's use synthetic division, and let us take x cubed plus 3x squared minus 3x plus 5 and divide it by x minus 1. Using synthetic division, we can set this up, pull out my 1 over here, write down my coefficients of 1, 3, -3, 5. Leave me a little room, and then I'm going to start by bringing my 1 down and multiply. 1 times 1 is 1. Now add 4. 1 times 4 is 4. Add straight down, positive 1. 1 times 1 is 1. Add straight down, I get 6. So I get the same answer. All this is really telling me is that if I get an answer right here, if I get anything other than a 0, then the graph of this function does not, then the graph of this function will not have this for a root. So this is how this example right here is how you're going to do your homework when you are asked to substitute and use synthetic division to prove the remainder theorem.